Here's the first project that I'd like to tackle. This is one of our most popular videos, and I'll include a link to it, but we made a small DIY CNC machine that worked as a pen plotter. It had some problems. It didn't have a Z lift, and it wasn't super rigid, and we still sell the aluminum angle as brackets, but it's not as flexible at first adjusting the size as I'd like, and again, we don't have the Z-axis. Actually, a viewer who was inspired made their own version, and I'll attach this or a link to this. But this was I thought this was a much better machine. It's got a lifting, a Z-axis lifting mechanism, and what I like about it is that you could adjust the size of the machine to whatever you want. So if you wanted a compact machine or a bigger machine. Here's the thing though, it has to be rigid enough. We're not going to ever do radial tooling with it, so we're never going to use it as a milling machine, but simply to accelerate and decelerate faster, you need to have, in this case, the two bearings on each seem to work. We only had one bearing in here, and this would twist. This seemed okay, but again, I want this thing to move faster, partly just because it looks cool, and that's fun to do. The goal here is to offer do another video on the build and DIY and show it with Fusion 360, but also from a commercial standpoint, we need to come up with a new version of this that we can sell as a kit. And I tried to build this version, and this has been sitting here for some time, and it's sort of taken apart right now. But we had our X going this way and the Y going the other way, and we had a little Z-axis head on it, and the problem with this is it was not rigid enough. What I liked about it was we were able to consolidate a lot of the hardware into these four corner pieces and this top block, and then we could just provide links to people where they could buy I think this is 8mm ground rod and the 8mm import bearings and so forth, which are very low friction. They work fine, but when this machine is assembled, it binds. It's not rigid enough, and I don't like the belting, the tensioning. It just needs improved. So the task at hand is to build a DIY CNC machine. It needs to be adjustable in size by the user. It needs to be something that we as Saunders Machine Works can manufacture certain parts for it that the individual is not going to be able to buy, like the aluminum blocks and so forth. It needs to have a Z-axis lift mechanism to use for a Sharpie as like a pen plotter. We also want it, and this part's pretty easy, to be able to use one of these Chinese lasers. These are actually pretty amazing, relatively low cost, so this just needs to be able to mount. The good news there is you don't need any sort of Z mechanism and the height for it. I want the first version to function off of Garble and NEMA 17s, which are the smaller size steppers, but I also want to use the same thing for NEMA 23s so that we can use clear paths. And with the clear paths, we'll probably want to use the Masso controller. So I think what that means for now is don't worry too much about it, but I think we want the mounting locations of everything to be able to support either a NEMA 17 or the larger NEMA 23. And then the goal is going to be able to make something, again, that can move fast. The 17s will be somewhat limited, but we could do NEMA 23 steppers, or we could do the NEMA 23 clear pass, and the clear pass should be able to move 1,000 inches a minute. So the machine has to be rigid enough, and I don't know whether that means we keep a belting system or we should switch to some sort of a screw. I did find these at one point, I think on Amazon, for relatively low cost, and I like this idea of getting away from the belting, but again, I don't have the time to figure out a solution. So some of this is the mechanical engineering, some of it is the Arduino and the project nature of it, some of it is also helping source the components, because I need to offer a solution, not just tell people to go find this, because this is sold as a kit, which is pretty darn cool. And you've got the stepper with the shaft that's got the ball screw that's got turned down. It's got the coupler on it. It's got the integrated ball screw inside of here. That's a solution. It's very difficult, I find, nowadays to tell people to go source these individual components and put them together and again on this track. Maybe we switch to something like 80-20. I'm very open. By no means do we need to keep this design of what you're seeing here, but the end goal is, again, to have an XY plus Z pen plotter / laser controlled by either Garble or Masso. Let me know what else, other information you need from me. Otherwise, looking forward to it.